All right, so I gave you guys 3 equations and I asked you to solve them.
Yeah.
So what does it mean to solve these?
Solve for whatever you gotta solve.
Wow.
In each of these, we have how many types of variables?
2
There's 2 variables?
or 1.
There's 1 variable. First one, I have an x in just one spot. Second one, I have 2 x's, but it's still just x. It's not x and y. So I'm solving for x, I'm solving for x. Each of these, I want to find out what value for x would give me the number on the other side as my output. So on this first one, I want to know what do we put in for x, and then after we do all this stuff to it, we're going to subtract, we're going to square, we're going to multiply, we're going to subtract again, and I want the final output to give me 25. You want to start on that one? So we are going to do that, but I've got just a couple questions first about these. Did you guys approach these differently?
Yeah.
Did the form that they were in influence the way you chose to approach it? Yes. How do you think you could convince someone that your way was the best? I heard a lively conversation going on here.
Because they was confused, and I was trying to see if they got the same answer I did. But they
He was all far away.
I got a 3x squared minus 48.
Did anybody use technology for this? Did anybody graph it?
Desmos. No, I did not use Desmos.
Are your answers exact?
Yeah.
Do you guys know what I mean when I say exact?
Oh, wait.
Whole number, or it's left in fraction form. Like you didn't have to do any rounding. That would be an exact answer. Okay. So let's look at number 1. Jay, you said you want to talk about this. If you have not already done so, we're going to solve this algebraically. So what could you do to solve it?
Look, I felt like it was just too much to do it the other way. So I added 2 to the other side to make it equal to 27.
Okay. Give me just a second to get this written down because I want to catch up with you. All right, so Jay said he added 2 to both sides. Is that allowed?
Yeah.
Yes. Does anybody remember what property that is?
I know, I just figured out how to do it.
This, what's it called? What do you do? No.
We added 2 to both sides.
And then I divided by 3 on both sides to get rid of the 3.
Okay. When you do something to both sides, that is a property of equality. So in the first step, Jay was doing the addition property of equality. What's happening here? Division property of equality. All right, so x minus 4 squared equals what? 9. Okay.
And once I separated it into x minus 4, and then I did you did it for like all the arrows.
Oh, you did double distribution there?
I did the double distribution to make it a quadratic function.
Okay. So x minus 4 equals 9. Jay said he double distributed here. So x squared minus 4x plus 16 equals 9. What did you do after that?
And then I did it combined like terms. So it should have been x squared negative 8x plus 16 equals 9.
All right, so x squared minus 8x plus 16 equals 9.
And then I subtracted 9 for both sides.
Subtracted 9 from both sides.
And then it'll be set equal to 0.
All right, so I'm going to bring this up and around here. X squared minus 8x plus, what is that, 7?
And then you just solve it.
So when you say, and then you just solve it, what are we doing?
Oh, you
Right,
multiply,
explain for the
you
people.
multiply your A term to your C term.
Ah, so what are you doing when you multiply the A and the C? Like what method are you using? Factoring, yes. Multiply A and C together.
Yes, 7.
B value is what?
Negative 8.
Negative 8.
Negative 7 and negative 1.
Negative 7 and negative 1.
Since the A value is a 1, you could just put x minus 7 x minus 1.
Yes.
job.
He was the only one that's talking.
All right. What do we do with it after
No,
this?
I didn't.
I mean, you set each equation equal to 0, so you set
Yes.
x minus 7 equals 0, and then x minus 1 equals 0. You solve it. So I gotta explain that too. Or
Give a round of applause, man.
That was such a great lesson.
All right. So Jay got x equals 7 and x equals 1.
and then I just plug it back in to make sure it works.
Subbed it back in to make sure it worked. Was it correct?
Definitely.
Okay. So I'm curious.
Definitely.
Did anybody approach it differently?
Yes.
All right. Tell me how you approached it.
I think I made it look like the other equation. Well, it made it look like the last equation.
You made it look like the last one, so you put it into standard form?
Yes.
Okay. So let's look at how we would do
I
that.
have a question.
Mm-hmm.
Well, I think I'll see it when we write it out, but
So tell me how you went about putting it into standard form.
I distributed the x minus 4, x minus 4 equal 2,
Mm-hmm.
and then I got x squared minus 8x plus 16. Yeah. And then does the minus 2 go on the outside of those Okay,
Mhm.
that's what I messed up.
Because the 3 in that original problem is only next to the parentheses.
Right.
It is not going to be distributed to that minus 2 because that minus 2 is way off by itself.
Okay, that's what I messed up with, so I'll kind of solve it.
Okay, so what would you do from here?
Add 2 to both sides.
Okay. So
Then you have
3.
3x squared minus 8x plus 16 equals 7. And then, yeah, and then I don't know what to do next.
Okay. Well, there's a couple things that you could do. This right here is almost exactly where J was, except he divided by the 3 before he did the double distributing. You double distributed, so you could get rid of that 3 out in front the same way J did. Or you can distribute it.
But then that's more work in the end, so that's why I just divided it instead of distributed.
I don't want to distribute it.
So I'm curious. I'm going to come back here and look at when Jay had it right here. Because I thought you were going somewhere different with it. What you did was fine, and you did get to a correct solution, so your method was certainly effective. But I'm looking right here. Can you guys see anything that I could have done with that other than double distributing?
To get rid of it.
I can square root it, right?
Yeah.
So let's square root both sides.
I never recognized square. That's what I did. Oh.
So x minus 4 equals, what's the square root of 9? Careful.
Plus minus 3.
Plus or minus 3.
Oh, plus.
Plus or minus.
I was looking.
I feel like I need some more room here. What can I do?
You have to add it. You have to
Let me
x
see.
equal
I
to
was like 3 times.
7.
All right. I'm carving out some room over here so that I can do this. Because I don't like it up there.
You really know. Okay.
All right, so x minus 4 squared equals 9. Square root it. X minus 4 equals plus or minus 3. What would I do to get the x all by itself here?
Plus 4.
Plus 4 on both sides. So I have x equals 4 plus or minus 3, which is going to give me how many answers? 2. One where I plus them together, and one where I minus them. So I would have x equals 4 plus 3, which is what? 7. X equals 4 minus 3, which is 1. Same 2 answers, right? Did anybody use technology for this? Okay.
You don't want to be humble.
All right. These are just some questions that I had for myself, and rather than walk around with sticky notes, I put them up here. we looked at this right here. We looked at the method of taking a square root, and a lot of people had recommended expanding the binomial. That's what it is when we double distribute. That's called expanding the binomial. Did you consider the other option? For those of you guys that did double distributing, did it occur to take a square root? Okay. Did both methods result in a correct answer? Yes. Which of the two methods do you think was easier?
The square root. I just say, see it. Basically, call me stupid in 3 numbers.
I said nothing of the sort.
I mean, that's basically what you said. I'm just saying.
Basically,
No.
my way is easier.
You thought your way was easier?
Yeah. It took less time.
Is it
I
kind
didn't
of a
do
matter of
this way.
opinion too?
Yes.
Yeah, it's like preferred methods. Some people are like, I never see the square roots. Or, if I take a square root, I always forget to do the plus and minus. So I feel safer going the other route. That's okay. What about this guy?
Just maybe.
Okay. So let's do that. What would it give me when I distribute the 6x? 12x squared minus 6x plus 10x minus 5 equals what? Equals 0. Do we have any like terms? Okay. So I'd have 12x squared plus 4x minus 5 equals 0. What did you guys do next? Multiply the a and c terms, which means you're doing what? You're factoring.
This one I failed calculus.
All right, so multiplies to negative 60, but adds to what? Adds to 4. What numbers will do that? Curious.
George.
Why did I say that was curious? Negative 6 and 10. We have them right here, right? Okay, so you found the two numbers that multiply to negative 60 and add to 4. What did you do with it then? Put them in parentheses?
Yeah.
So tell me what to write down. I'm going to do what you did.
I put this negative 6 at the top because it was easier.
Negative 6 at the top.
It's 12x squared minus 6x and put in parentheses.
Okay.
And then put in parentheses 10x minus 5.
Okay.
And then you take out your like terms. So on the first one, it would be 6x. On the outside parentheses.
Okay, so I'm going to take out a 6x, and what would that leave me with?
2x. And then minus 1.
Curious.
I'm saying, like, I'm trying to solve the equation. Like, we get it, you see it. And then on the next one, you take out a 5.
Okay, positive or negative 5?
Positive.
So I'm going to put a plus. What do you have left over?
2x minus 1. And then in parentheses, you put 6x plus 5.
Hmm.
And then in the other parentheses, you put 2x minus 1. Nice.
Who knows why I keep saying,
You're a teacher, so you know all the methods.
Right.
Niles, a little louder.
I say because everything that we look for and solve for is in the equation.
Yeah, I want you guys to look real close at where we are now. Where did we start?
The same.
That is the exact. So far, all we've done is like run around the bush and come back, which is, nothing is wrong, but have we gotten anywhere? What did you do after this?
I said each parentheses equal to 0, so I put 6x plus 5 is equal to 0. And you minus 5 on both sides. 5 by 6, maybe 5, 6. And then same thing for the other one. Then you get x is equal to 1.
Does anybody see how we could have done pretty much the same thing but with less work?
See, I wouldn't have known that because instantly when I see parentheses like that, I instantly know the factor. So
They are factors.
I mean, not factor. Distribute. That's when I instantly know to distribute.
Well, there's nothing wrong with distributing. Did distributing result in a wrong answer? No.
Of course, it would be wrong. I mean, it's me. Big brain.
We did not get a wrong answer by any stretch of the imagination. Were we doing the most? Could we have jumped to this part right here?
Yeah. Yeah. Oh.
Hey, I'm following y'all's lead.
Don't you know that though? Like, you can do that for every factor one.
So here's what I'm looking at. In this original problem, it's equal to what?
0.
0. I want you guys to think about this for a minute. And if nobody else has ever pointed this out in the past, first of all, I'm sorry. Second of all, you're welcome because now you know. If I know that the answer to some kind of a multiplication problem is 0, and I know that one of those numbers is, say, 5, just pretend, what would the other number have to be if my final answer is 0? It has to be a 0, right? What about if I know one of those numbers is x? It's just something. The other number has to be 0. The only way I can take two things and multiply them together and get an answer of 0 is if one of those original two things is already 0. If this was not equal to 0, if this was equal to, say, -6, see, just pretend for a minute with me. If this was equal to -6, could we jump to right here? No. If it was equal to -6, then we would have to do what J did over here. You would have to double distribute, and then you'd have to get it set equal to 0 so that you could try to factor it, right? So the way Jay was thinking through it wasn't wrong at all. And in certain circumstances, that's the only way to go. In this one, because it was already equal to 0, we could have taken a bit of a shortcut. Yes. If it's not equal to 0, you have to do it Jay's way. If it's already equal to 0, we could have hopped right here.
Well, make sure that's on the test.
But like 4 problems, not 16.
What form is number 3 in?
Standard.
Standard form. Is it factorable?
I don't know.
I heard no, and I heard I don't know. How do we determine whether or not it's factorable? Multiply A and C together. So what are we multiplying together? 9 and -6. So that gives me -54. But adds to 4.7. Yeah, that's, I mean, I suppose there might be numbers that do that, but I am not spending all day going through a bunch of decimals trying to figure out what they are. So, does not factor. Does that mean that it's no solutions? No, it just means that they wouldn't be pretty. So what could we do to approximate these solutions then? Well, even if we rounded it, multiplies to -54 but adds to 5?
Sam, well, you have to make the equation equal. I feel like if you did it to one thing, you have to do it to all of them. So just round all the numbers. I don't know. I'm just guessing. But we'll figure it out.
What else have we practiced doing this week? What could you use to approximate these solutions?
Oh, the table chart.
Yeah, we could do a table. We could do a graph, right?
I don't even know how to do that, to be honest.
Well, let's talk about it. Because there's sometimes that we know how to do an algorithm over and over, but if you don't know what you're finding, then when you move into a new situation that you can't use the old method on, you don't have the understanding to be able to look at something new and go, oh, I see how this is related. I want you guys to be able to do that. So let's look at a table. I'm going to hop into Desmos for that, because Desmos makes tables for me, and I'm lazy. All right, so tell me what that equation is again. I remember the 9x squared part.
Plus 4.
9x squared plus 4.7x minus 6. Okay. You said it equals 0? So if I'm looking at a graph, it is a parabola. Where would I look for equals 0?
Or less than 1.
The x-axis. So I'm looking here and I'm looking here. Just from the way this graph looks, can you ballpark for me what the solutions would be?
Probably like 0.7.
So something around 0.7, because it's in between 0 and 1, right? Yeah, negative 1 point something. Not very big. I'm going to come over here and I'm going to turn this into a table. Do you guys remember how to make this, give you a table? This click wheel right here, little gear. We're going to click on that. How can I use this table to get more precise than what I'm seeing right here?
Add more numbers to it.
I can add more numbers to it. So let's see. Oh, come on. You're not going to work unless I go here. Okay. So it's undefined only because I haven't typed anything in yet. Why did I click in between the -2 and the -1? What did we see about the graph? Yeah. It's a little bit farther than -1, but it's not all the way to the -2. Give me a number that we could try here. Ballpark that for me. I'm going to type it in. -1.1, okay. -1.1. Ooh, is that pretty close to 0? That's what we want our output to be, right? Okay. Can we get closer? Should I try a bigger number or a smaller number? A bigger number, so closer to 0? Because when I go this way on the number line, those are bigger. When I go this way on the number line, those are smaller. So should I go closer to 0 or farther away? Closer to 0. So give me something that's closer to 0 than -1.1. -1.05. Ooh. Did we get closer or farther away to 0? Farther. So should we modify our guess here? What should I try instead? -1.2. Okay. Turn to a positive number. That one's still closer to 0 though, right? So maybe -1. Hold on. Oops, that's not what I wanted to do. Tell me what to try. -1.04. I think this one's like the closest we've gotten so far, right? 1.15, okay. Ooh, that one's pretty close. Here we have a -0 point. Here I have a positive 0 point. So it's somewhere in between these two. Okay, let's try it. Closer. What happens if I do 3? Closer. What happens if I do 2? Really close. So somewhere in between -1.1 and -1.12, when it switches between a negative and a positive, I know it had to cross 0 there. Because if it starts negative and then the next number is positive, it had to go over that 0 line, right? All right, so we've kind of estimated this one. Can you help me estimate the other one? What two whole numbers is it between? 0 and 1. Give me something to try. 1.1? That gave me an output of 10.
So between 0 and 1.
Between 0 and 1.
That's great.
It is. I want to try a number that's between 0 and 1 because over there on the graph, we're between 0 and 1 for where it's crossing. 0.7. Okay. We're getting closer to 0, right? Can we try a different guess and get closer? 0.5. See, 0.5 gives me this. You said 0.4. That's too far. There's 0.5, 0.6. Ooh, that one's really close to 0. How could I get really precise with this? I can click on my graph, right?
So you made us go all over for what?
Well, I want you to understand how a table works.
Oh, I get it. But will we be able to use that on the test?
Depends. I might give you part of a table and ask you to try some other values.
No, that doesn't even work like that. 'Cause you see how-
More importantly, because I don't you guys are really close to the end of your senior year. Is it on the test only matters so much. How will you use this type of information when you're out of high school? You might not care about parabolas themselves. But can you look at graphs and get important information from them? Can you look at a graph and figure out what part of this stupid picture you're even supposed to be looking at? Like, having a graph is one thing and that's great, but what do you do with that then? A lot of times in business situations, they don't necessarily give you the pretty graph, or they might, but there's no numbers on there. But then they give you tables to look at. And your eyes start to cross because you're like, that's way too much information. How can you make sense of it, especially if you're supposed to do something with it for your job? Those are some of the big takeaways that I want you guys to grab out of here. Is it on the test? Is it not on the test? I'm not as concerned about that as I am making sure that you guys have the skills to be successful once you don't have tests anymore.
Can't wait.
So I'm curious. How can I use technology to solve this?
Plug it in, see computer game.
Okay, so let's look at that. I'm going to put just the left side in. X squared plus 9x squared plus 4x minus 1. (9x squared plus 4.7x minus 1). What was it going to be equal to? -6. Look at the graph. Where's this equal to -6? It's not.
It's because you gotta add it.
How do you know?
Because it never touches.
Where's -6?
Down.
Right here. Does my parabola ever go that low? No. Even if I were to add it to both sides, like you suggested, if I add 6 to both sides, that would give me this, and now I've got it equal to 0. Where does this equal 0? Nowhere. So even when I do some algebraic manipulation to it, I still get the same big idea result. It's not ever going to hit the value that I'm saying that it's equal to. So Monday, I am sure that every single person will be in attendance. I've been teaching too long to lie. I know this weekend is prom. I know what that means for Monday. There's a homework assignment that's due on Tuesday. If you're here on Monday, that's what we're doing in class on Monday. If you're not here on Monday, that's what you're expected to do for Tuesday.
All right. See you on Monday.
Exactly. I will see you all on Monday. Right? If you guys need anything, you know how to get a hold of me. Please don't hesitate.